By now you should know what sine, cosine, and tangent are. Those are special trig ratios. But this one might be a bit of a curveball. What is cosine with a -1 over it? Well, to talk about that, I do not want to dive too deep into inverse functions. That's what this is. This is an inverse function. But I do want to remind you of the general format of something. Sine of theta equals opposite over hypotenuse. And cosine of theta equals adjacent over hypotenuse. And likewise for tangent, opposite over adjacent, but it doesn't look like we need tangents in this particular problem. Maybe in the version you're looking at you do, so I'll just write that on here too. Tangent equals opposite over adjacent. And now, let's talk about that inverse thing. What inverse means is you just undo an operation. Like if we do addition, the inverse of that is subtraction. And if you're balancing an equation, you cross out addition using subtraction. Well, likewise, if I take the inverse cosine of the cosine of theta, what that leaves me is something that only has theta. It's as if you crossed out the cosines. Okay, that's a little bit of hand waving, but you can think of it that way. And this equals the inverse cosine of adjacent over hypotenuse. So look at what we have here. Theta equals the inverse cosine of one side divided by another side. Okay. Now, let's talk about what we were given in this particular problem. I want to compare it to this. Notice that theta is an angle. So if I can figure out cosine inverse up here, that's where I'm looking now. If I can figure out which one of these sides corresponds to the adjacent and which one of them corresponds to the hypotenuse, I should be pretty good to go. Let's see, there's A. Okay, so this is my adjacent side right here. And this must be my hypotenuse down here. So where's the angle? Well, it's got to be right here. See, adjacent is next to theta. Hypotenuse is the diagonal. So that's my angle. And that angle, remember, theta equals this thing. Theta equals this whole thing right here that I'm circling. And I plug that into here. So if this is theta, what's the sine of theta? In other words, what's the sine of the inverse cosine of all that other stuff? Right? That's what I'm asking. So the sine is the opposite over hypotenuse. That means B, right? That's my opposite side right here. B over the hypotenuse. We already talked about the hypotenuse. That's the square root deal. Square root of a squared plus b squared. And if we look on our list, there it is. So I think the challenge in this problem is just getting your heads around this idea of an inverse trig function. When you see inverse cos, inverse tan, inverse sine, all it's doing is it's talking about a particular angle. It's your job to find that angle in the triangle and then substitute it in here. Like that whole thing was theta.